Good afternoon, students. This is my first video in a separate channel. AS and A level questions we are going to discuss. First, in AS level, waves question we are going to discuss today. Some 4 questions I will discuss in this video. First question, look at this. Which of the following is correct for stationary waves? Stationary wave, okay. Actually, what is the meaning for stationary wave? Stationary wave means two waves should travel in opposite direction. For example, if I am having one end here and another one end here, one wave motion of a particle is represented like this. And another wave motion of that particle should be opposite to the wave motion what I have represented earlier, right? So one will be in one direction and another should be in the opposite direction. So it will produce nodes and antinode. Where it will produce node, where it will produce antinode. That is the important point. For example, for simple representation, I am going to represent this wave motion as a circular part. That is, some wave motion can be represented in a circular displacement, right? For example, look at this. If the particle is here, one particle is here and it is moving in a wave motion. That is, in wave motion means there will be a two displacement, x displacement and y displacement will be there. So only one displacement will be represented as a circular motion. So circular motion will be like that, one circular, that is one axis displacement. For example, this is an y axis displacement, take like that. So y displacement for first particle will be like that, and the second particle, so the particle will be started here and the particle will be here at some moment and here at some moment and here at some moment. So if the particle is started here, the next particle should be start and at the same position, but it should travel in an opposite direction, right? So the next particle I'm going to displace, I'm going to show that. Look at this. So the next particle I'm going to show, but it will be in the opposite direction. That is, it will move like that. Next particle will be in the opposite direction. So the next particle is moved like this, right? So the particle will be here and here, here, here. So the particle movement has been represented like that. Actually, only one axis displacement I am showing here. This is the y axis, this is the x axis, means it's a wave motion. But according to get the convenient uh, representation, I'm taking only the y displacement. So y displacement or x displacement, whatever may be, we can take any axis displacement in a circular path. So one particle is moving like that and another particle is moving like that. Now I'm going to show both the particle in one circular motion. If the particles are started here, so this is the particle, this is the one particle and another one particle are started here. First, the particle, that is the orange color particle, will move here. Sorry, wait a moment. The orange color particle move in this way and will be placed here, and the green color particle will move in this way and placed here. So two particles are at the opposite place, right? So the phase angle between that one will be 180. That is called out of phase because the particles are not at all mated, right? Uh, that is, the particles not at all met here. And this is 180-degree out of phase. And if the two particles are at the same position, look at this here, the two particles are at the same position. This is in phase. Here, the bond angle will be 0. That is called in phase. Here the bond angle will be 0 degree in phase. Again, the particle is moving like this. The orange color particle moving like this and kept here. And then another, that green color particle moving like this and kept here. So both the particles are placed in the same position. That is called, once again it met, right? So they met. That is why the bond angle will be 0 again. So 180-degree will be here, and again the particle moves here, means again 180 will be there. So out of phase, in phase, both the phase are created here. So first case, the out of phase will give node. That is 180 degree will give node, and 0 degree will give antinode. So antinode means what is that? The maximum displacement. So this is also 180 degree, this is antinode. So this is antinode, this is node actually. So here nodes will always in phase, that is 0 degree. Antinode will always in out of phase, that is 180 degree. That is the representation of stationary wave. So we first learnt about the stationary waves. Now we are going to solve that question. Look at this. Between the two nodes, the amplitude of the wave is constant, right? Between the two nodes, the amplitude of the wave is constant. Here they are saying the amplitude of the wave is constant. It's not like that. Actually, look at this. The amplitude here will be this one. This is the amplitude here. I will represent in another color. This is the amplitude when the wave node is when between the node. And here the amplitude will be like this. So this amplitude is small and this amplitude is high, right? This is the maximum displacement. That is another one amplitude, right? So that is amplitude will be the maximum displacement. But here this is not an amplitude, this is a displacement along y or x axis. So the amplitude will be maximum at one position only, but in all other position the maximum displacement will be differing. So it's not a constant between the nodes. That is why it should not be the answer. And the second one, the waves producing the stationary wave must always be 180 out of phase. That is also wrong. We need out of phase as well as in phase difference. Right, that is, I will first draw the first harmonic and the second harmonic. Look at this, the first harmonic will be always like that, and the second harmonic will be like that. Look at this, here one node, antinode, and two another one node, here one node and another one node. So here one node. So here there are two nodes. Here there are three nodes, so it is not a double here. But what they are saying, double the separation of nodes for the first harmonic. It's not a right answer. And if you are taking for antinode, it will be right, right? Here only one antinode will be there, but here two antinode will be here. But what they are saying, nodes. That is why here, if there are two nodes here, there will be three nodes. And then the next one, between two nodes, all parts of wave vibrate in phase. That is why it is giving some displacement. So in phase means it will give uh, some displacement. That is, overall displacement will be there. Some amplitude will be there if there are in phase. If there is an out of phase, then we will get only the node. If there is an in phase, we will get some maximum displacement according to the superimposition of that wave. So superimposition will be there between 0 to 180. In 0, there will be a maximum amplitude, and in 180, there will be minimum amplitude. So between the two, there will be some displacement. So that is called in phase difference. So D is the right answer. This is a theoretical question. You have to learn that again and again by passing this video, and you have to refer that some notes. If you don't know about that again, or if you can't at all clear about this concept by this explanation, please inform me and I will give a better explanation in the separate part. I will concentrate only on this question alone. Okay. And then question number 2. Sound waves cross boundary between two media X and Y. The frequency of the waves X is 400 Hz. The speed of the waves in X is 330 meter per second. Okay, so sound wave is crossing a boundary between X and Y. So when the wave is crossing a different boundary, the frequency will be the same. So frequency, what is the frequency? What is the symbol for frequency in physics? Actually, you will, I think in AS level, you will learn F, right? So F is the frequency. So F is equal to C by lambda. So C by lambda for light. For some waves, C is the velocity of light. But now I'm going to take that as B because I'm going to consider some different wave than the light. So this is a sound wave, right? So velocity I have taken like that. So velocity will be same for both, sorry, frequency will be same for both the case. Then that is why in the medium x, velocity of the wave for x medium and wavelength of the wave in the x medium will be equal to, because frequency is constant, right? That is why velocity of wave in the y medium and wavelength of that wave in the y medium will be equal. So the ratio will be equal. If you are solving that, that is Vx will be 330 and the lambda x, we don't know about that lambda x, right? So, okay, I'm going to take as such, and then velocity of light in that that one will be 1320, and the lambda y also we don't know, right? We need the frequency for something, right? First one we will get the x medium frequency by substituting that formula, that is lambda x. Lambda x we can get from this one. So f they have already given 400, right? So lambda x will be 330 divided by 400. So lambda x, if we have taken that, frequency will be 400, yes, 330, yes, everything right. I think we can substitute in terms of lambda x. So 330 divided by lambda x will be 330 divided by 400. So it will be like this. So 1320 divided by lambda y. So 330 will be cancelled, and then lambda y will be 132 divided by 40. So what we will get? Yes, 3.3. So already I told you that frequency will be constant. So 400 frequency will be there. So this is the right answer. And then question number 3. Yeah, this will be somewhat difficult to understand that one. If you are understanding that concept, you can answer the question if they are asking in different way. Okay, then let us see that. Look at this. Two pulses are going to meet each other, right? But the two pulses are out of phase. Look at this. This pulse is like this. This pulse is like this. So always the displacement will be. Look at this. The wave. If you are considering the particle displacement like this, here the particle displacement will be like this. So always there will be 180 degree phase difference between the particle. If the two waves are meeting each other, what is happening? Look at this. Here, if the particle displacement here, always there will be a 180 degree displacement, again 180 degree displacement, again 180 degree displacement. That is why I'm saying this is an out of phase. So what will happen in the middle phase? If they are superimposing here in the middle phase, once again we will get to the zero amplitude. So the zero amplitude will be there in the middle phase. Zero amplitude, always it will not be zero amplitude, because the interfacing the pulses are moving, right? So they will superimpose at this position. After that it will move. So this will move this way, this will move this way. So at the superimposable position we will get to the zero amplitude. That is why this should be the right answer. If you are taking this one, look at this. The pulses are not at all moving. The upper pulse is like this, the lower pulse is like this, right? There is the lower amplitude, the upper amplitude, positive amplitude will be like this, the negative amplitude will be like this. So this will not be the right answer. Always it will not be a zero, because at the superimposing position only it will be a zero. And in case of D, after the superimposable position, there will not be any change in that amplitude, frequency, wavelength, and everything. But here there is a change in the amplitude. That is why we should not take D as a right answer. So at the middle part, the amplitude will be zero. For example, if they are asking like this, if the two pulses with the same, that is, for example, one pulse is coming like this and another pulse is coming like this, what will happen? So if the two pulses are coming like this, here look at this, they are in phase. So in the middle case, that is at the if they are moving like this, in the middle case, at the superimposable position, for example, this is a superimposable position. At the superimposable position, we will get the maximum amplitude, because at the superimposable position there is a constructive interference. Constructive interference means in phase. So in phase will be there, that is in phase interference will be there. That is why in phase superimposable means there will be a maximum amplitude, and again the pulses are moving, right? So after that we will get, after that region, this pulse, that is this pulse will be here, and this pulse will be here after that superimposable, because the two pulses are moving, right? Okay, let us discuss the further question in the next video. Thank you.